All right, hi folks. This is Larry Maslino. I'm recording a short video for Module 4, and a few students were asking about solving quadratic equations. So I thought it would be helpful to do a few examples from the skills practice to help you work through a few of these homework problems. Now, I'm here in Module 4 skills practice, and I'm going to start with problem 11 because this is basically where quadratic equations are discussed. Folks, remember, when you are in my labs, you can use this view an example button or help me solve this, or you can also open up the textbook. So please, folks, use these help buttons as needed. All right, let's take a look at this one to get started. It says determine whether or not the equation is quadratic. Well, of course, I have to know, what does quadratic mean? So, all right, I had to plug in my tablet. Well, some of the equations we've been working with might look like this. And if you notice, this equation has just x to the exponent 1. When x to the exponent 1 is present, we call it linear. But if we have an x to the exponent 2 like this in the equation, we call this quadratic. So a quadratic equation has x to the exponent 2 in it as the highest exponent that appears. So let me take the equation they're giving us and try to figure out if it's linear or quadratic. Before I can answer that, let me take this x and multiply it inside the parentheses. X times x is x to the 2, and x times this 5 back here is negative 5. Well, of course, right away I can see it is quadratic because I'm seeing an x squared present. So yes, quadratic. So I know the answer is going to be A, because all the answers B, C, and D are saying the equation is not quadratic, but this equation is quadratic because of the presence of x squared. Now, when you have a quadratic equation, usually we want to write it in this format: ax squared plus bx plus c equals 0. So we'd like to get the equation set equal to 0. And we'll see why that is helpful in just a few minutes. But I'm going to go ahead and do that. I'm going to add 6 to both sides because I want to cancel out this negative 6. Oops, I'm sorry, I should have written a 5x here. So that cancels out. That's a 0. So what I have here is x squared minus 5x plus 6 equals 0. Now I match up to identify the values of a, b, and c. Well, in front of the x squared, I can really think of this as a 1. So the a here matches up to 1. The b is whatever number is sitting in front of the x, while our b matches up to negative 5. And the c is whatever constant is over here on the right-hand side. In our example, c matches up to 6. So our answer is yes, this equation is quadratic. A is 1, b is negative 5, and c is 6. All right, well, let's go to the next example because now they're going to start asking us to actually solve these quadratic equations. Let's go to the next one. All right, so this says find all the roots. Well, the word roots is another name for solutions. So roots means solutions. So they're asking us to solve this quadratic equation. I know it's quadratic because, again, I'm seeing this x squared here. Well, there's a couple of ways you can solve quadratic equations. One method to solve quadratic equations is to use a method involving factoring. The second method is to use what's called the quadratic formula. Well, usually we try to see if factoring works first because factoring is a little easier. If I can't use the factoring method, then I'm going to use the quadratic formula method. Let's try the factoring method. How does that work? Well, here's what you do. Step 1. So this is the factoring method to solve quadratic equations. What we do here, step 1, is get the equation set equal to 0. Well, it turns out in this example, it is set equal to 0. So I don't have to do anything for step 1 here. So I'm just going to copy it down. Step 2 is factor the one side of the equation. All right, well, let me come over here. I'm noticing this is 16x squared minus 25. Well, I'm remembering a way to factor called the difference of two squares. And if you remember, the way this works is if you have an expression that looks like a squared minus b squared, it factors as a plus b times a minus b. So what I'm going to try to do is rewrite this as a quantity squared minus another quantity squared, because then I can factor it according to this template up here. Well, let me rewrite 16x squared as a quantity in parentheses squared. So I'm going to write this as 4x in the parentheses, because 4x squared gets me back to 16x squared. And 25, I'm going to rewrite as 5x squared. So really, I'm thinking of this 4x as the A quantity and this 5 as the B quantity. All right, let me do the factoring then. It says to factor it, right, as A plus B times A minus B. All right, well, we just figured out that the A quantity really matches up here with 4x. So I'm going to put a 4x in the front for A. And I'm going to put a 4x in the front here for A. And our B expression is a 5. So in the back here, I'm going to put a 5. In the back here, I'm going to put a 5. And this template says make the first parenthesis be a plus sign, make the second parenthesis be a subtraction. All right, let me go to the third step of this factoring method. It says set each factor separately equal to 0. What that really means is set each parenthesis separately equal to 0. Separately equal to 0. The reason I'm doing that is if you have one quantity times another, let me give you an example. What if I have 7 times something equal to 0? The only way this could be true is if in the red box I put a 0. If you have two numbers multiplying together to get you the answer 0, the only way that equation can be true is if one of the numbers themselves is equal to 0. So what I do then is I take this parenthesis, set it equal to 0, and separately take this parenthesis, set it equal to 0. So I'm going to end up with two different answers here. Well, let me start off here subtracting 5 from both sides. So that means 4x equals negative 5. Divide both sides by 4. So it looks like I'm ending up that x equals negative 5 over 4. All right, that's one answer, one solution. Let me come over here. I'm going to add 5 to both sides here. That cancels out. So I get 4x equal 5. Divide both sides by 4. And it looks like we're ending up where x equals 5 over 4. So it turns out when you solve these quadratic equations, you get two answers. And remember, my math lab wants us to use a comma to separate. So I'd be entering my answers here as negative 5 over 4, comma, 5 over 4 like that. So these are the steps to use the factoring method. First, get the equation set equal to 0. Sometimes it's already set equal to 0. Step 2 is factor the one side. That's usually the tricky part, is the factoring aspect. And then step 3 is set each one of those parentheses separately equal to 0. That's going to give you two simple equations to solve, though that will give you the two solutions that you're after. Remember, the word roots really means solutions. All right, so let's do another one. Let me go to, let's see what the next one is. Yeah, let's do this one because we'll follow the same method here and see if we can use the factoring method. All right, so let's do it. Factoring method to solve quadratic equations. Step 1, get the equation set equal to 0. Well, now I do have to do some extra work here. because this equation is not set equal to 0 to start with. Let me write it down. Here's what we got. X, 2x minus 5 equals 7. Well, I'm going to start out multiplying this x inside the parenthesis. X times 2x is 2x squared. And then x multiplying this 5 is a 5x equals 7. But remember, I want to get the equation set equal to 0. So let me subtract 7 from both sides, because that will get me a 0 on the right-hand side. All right, so I think we've got the equation set equal to 0, so step 1 is done. Step 2, factor the one side. All right, well, this is going to be a little tricky, but let's try to factor this left side here. I'm going to try to factor as one parenthesis times another. Let me start off with these front two blue boxes. These two blue boxes have to multiply to get me back to the 2x squared that I started with. So I'm going to try putting a 2x and an x here. Because I know 2x times x will get me back to the 2x squared that I'm starting out with. Let me come to these red boxes. Well, the red boxes have to multiply to get me this negative 7 back here. Well, I'm going to try 1 and 7 then. I'm going to put a 7 here and a 1 here. This is called trial and error. So I'm just trying some different combinations here to see if I can come up with the right factoring. All right, and I'm going to make this a minus and a plus. I know I have to make these different signs because I'm ending up with a negative 7 back here. So I need a negative 7 to multiply a positive 1 here. All right, before I do anything else, I want to check my factoring because I need to know, did I really do this correctly, or is my guess here incorrect? If my guess is incorrect, I'll go back and try something else. I know I need to end up with a negative 5x in the middle here. Let's double check it. 2x times x, that's 2x squared. 2x times 1 is a 2x. Let me come here. This negative 7 multiplies x, so that's negative 7x. And this negative 7 multiplies 1, that's a minus 7. Let me see what happens here in the middle. I have a plus 2x and a minus 7x. Yep, that is minus 5x. So that tells me that we did the factoring correctly. All right, I'm ready to go to the last step. Step 3, set each parentheses separately equal to 0. Set each parenthesis separately equal to 0. All right, let's do it. I'm going to go ahead and take the first parenthesis, set it equal to 0. So that's going to be 2x minus 7 equals 0. And then we'll take this other parenthesis and set that equal to 0. You can notice we're going to end up with two separate solutions. All right, here I'm going to add 7 to both sides. I'll cancel this out. So I got 2x equals 7. Divide both sides by 2. So I'm coming up that x equals 7 over 2. That's one answer. And over here, I'm going to subtract 1 from both sides. That gets me x equal negative 1. That's the other answer. So I have my two answers. It says use a comma to separate. So I'm going to enter this then as 7 over 2 comma negative. By the way, you can always check your answers in these equations. Take each one of your solutions and plug them back in the starting equation. And you should end up with a true equation as a result. If not, if you don't get back to a true equation, it tells you your solution was incorrect. All right, let's do a couple more. Let me come to this one. Now, I'm noticing this one says solve the equation using the quadratic formula. So I have to know, what do they mean when they say the quadratic formula? Well, here are the steps to solving a quadratic equation like this using the quadratic formula. All right, the first thing I need to do is get the equation set equal to 0 again. All right, then compare the equation to the standard form. It looks like ax squared plus bx plus c equals 0. And write down the values for a, b, and c. Step 3, plug these numbers for a, b, and c into the quadratic formula. Now, the quadratic formula looks like this. It says x equals negative b plus the square root of b squared minus 4ac over 2a. That's one answer. But there's a second answer that says write it as negative b minus the square root of b squared minus 4ac over 2a. Remember, for these quadratic equations, you're going to end up with two answers. So this is going to give us like answer A and answer B. All right, let's do it for our example. Here's what they're giving us. X squared equals negative 3 subtract 4x. But I want to get this equation set equal to 0. So let me move these terms on the right-hand side over to the left. I'm going to start out adding 4x to both sides. I'm trying to get a 0 on the right-hand side. So this cancels out. So I have x squared plus 4x equals negative 3. All right, well, I'm going to add 3 to both sides now to finally get this set equal to 0. I'm going to add 3 to both sides. This cancels out. And I get x squared plus 4x plus 3 equals 0. All right, well, let me go ahead and compare this to ax squared plus bx plus c equals 0. Well, the number sitting in front of x squared here is a 1. So I'm going to write down that a equals 1. Our b number is the number sitting in front of x. Our b number is a 4. And our c number is the constant over here, c equals 3. All right, so I have a, b, and c identified. I'm going to go ahead and plug them into these equations. Let's start up here with this first one. It says take negative b. Well, that's going to be negative 4 plus the square root. All right, now we need b squared. B squared is going to be 4 squared minus 4 times a. Our a number is a 1 times c. Our c number is a 3. All over 2 times a, which is 2 times 1. All right, let me go underneath the square root and work this out. Here's what we got. I'm going to do 4 squared. Well, 4 squared is 4 times 4. That's 16. Minus, now let me do this multiplication here. 4 times 1 times 3. Well, that's 12. All over 2. But under the square root sign, 16 subtract 12 is 4. So this is going to be negative 4 plus the square root of 4 over 2. But the square root of 4 is a 2. So this is a 2. So we're going to end up with negative 4 plus 2 over 2. On the top here, I have negative 4 plus 2. That's a negative 2. Negative 2 over 2 equals negative 1. So here's our first answer, negative 1. All right, let's go and get the second answer, the second question. Well, it's almost the same. It's negative 4 minus the square root. Now, I already worked out the square root. I got the square root of 4, so I'm not going to work it out again because it's going to, it's exact, this square root is exactly the same as this square root. So if I worked it out to be 4, up there, it's going to be 4 here too as well. Square root of 4 is 2, so this is negative 4 subtract 2 over 2. That's negative 6 over 2. That's negative 3. So we came up with two answers. Negative 1, comma, negative 3. Okay, folks, so these are the steps to use a quadratic formula as the method to solve an equation like this. You can use the quadratic formula to solve any quadratic equation. All you have to do is identify the values of A, B, and C, and then you plug into the kind of the messy quadratic formula equation. By the way, folks, sometimes you see these two equations down here written in kind of a shortcut way, because instead of writing it out as two equations like this, sometimes you see it written as x equals negative b plus or minus the square root, like this. But I think it's better to write it out as two separate equations. This way you don't get confused. The first equation has a plus sign on top. The second equation has a minus sign on top. So this is the way you'll generate the two different solutions that you're looking for. All right, let's do a couple more. All right, let me help you set this one up, and then I'm going to let you try it. So again, this says solve using the quadratic formula. All right, so here's the equation they're giving us. 0.22 z squared minus 0.14 equals 0.62 z. Well, I know I want to get this equation set equal to 0 as the first step. So let me subtract this negative 0.62 z from both sides. That's going to get me a 0 here. So it looks like I got 0.22 z squared minus 0.62 z minus 0.14. Well, I'm going to compare this to ax squared. Of course, here we're using z squared minus, in fact, let me write it with z squared. I guess that's going to be better. So instead of using x, we'll use z. So it's going to be az squared plus bz plus c equals 0. All right, well, I'm noticing a matches up to 0.22. B matches up to this number negative 6.2. And C looks like it's going to be negative 0.1. Of course, now I'm just going to go and plug into x equals negative b plus the square root of b squared minus 4ac over 2a. That'll be the first solution, and the second solution is when I use the negative sign on top like this, the subtraction sign. This is a job for your calculator, right? Because you're going to be working out messy decimals, so you could just plug these into the calculator. All right, let me just show you how that, let's plug it in just to show you how it will work out here. Let's do this one up here. So it's going to be negative b. Well, that's going to be the negative of negative 0.62 plus the square root. Now we need b squared. Negative 0.62 squared minus 4 times a. The a value here is 0.22 times c. The c is 0.14. All over 2 times a. That's 2 times 0.22. And of course, you can do this on your calculator. All right, folks, let's do one or two more. All right, now, when you're working with that quadratic formula, let me write that out again. X equals negative b plus the square root of b squared minus 4ac over 2a. This is one of the solutions. There's this quantity under the square root. This quantity, b squared minus 4ac, has a special name. We call this the discriminant. So I can just work out the value of this expression. Here's what I'm going to do. Let me start out with this equation they're giving me. Remember, I want to get this set equal to 0, so I'm going to add 8 to both sides to get started. That gets me 4w squared minus 4w plus 8 equals 0. Compare this to aw squared plus bw plus c equals 0. Our a number is a 4. Our b number is a negative 4. And our C value is an 8. So now I can just plug into this discriminant. All right, first it wants B squared. Well, that's negative 4 squared. Minus 4 times A is 4, times C is 8. All right, I'm going to work this out. This is going to be a 16. Let's see here. We got 4 times 4. That's 16. 16 times 8 is 108, I think. No, 128. Yeah, 128. No, 108. What am I doing here? 108. Yeah. Well, this works out to be a negative number, right? This is going to be negative 96. All right, so that's the value of the discriminant. Let me go ahead and type that in, because then there's going to be a part B to this question. Let me go back for a second. I think I did my multiplication wrong here. 16 times 8 is 128. Yeah, it's 128. Oops, I had it right originally. So let me fix that. And then 128 minus 16, 16 minus 128 is negative 112. All right, so this is the value of what's called the discriminant. So let's type it in so that we could see part B of the question, negative 112. Okay. So it says determine the number of solutions that it has. Well, if you notice here, we have a negative answer to the discriminant. So when we work this out, here's what we would end up with. Negative B, that would be negative 4, plus the square root of negative 112 over 2 times 4. But when you take the square root of a negative number, if you remember, that's going to generate imaginary solutions, imaginary numbers. So because we ended up with a negative number for the discriminant, we are going to end up with imaginary solutions. So we're going to go with this answer here, imaginary solutions. Okay. And folks, this would be a good one to use the view an example, because that would show you, different examples of what this discriminant could work out to be. All right, folks, let me do, let's do one more maybe. Let's do an example like this, because here we have to translate a word equation into a quadratic equation. So let me give you some guidelines on how to get started here. All right, well, the first thing you have to ask yourself is, what are you being asked to solve for? What are the unknown quantities? And what I want to do here is let x equal the unknown quantity that we know the least information about. All right, well, they're asking us for the dimensions of this rectangle. Well, dimensions means find the length and width. And I'm noticing they're saying the length is 2 more than the width. Well, I don't know anything about the width. I know a little more about the length. So I'm going to let x be the width. Now, I don't have to use the letter x. I can use any letter I want. I'm going to change it because I could see they're telling me to use w as the unknown quantities. Let's use w just to be consistent with their instructions. All right, now we need step 2. We need to come up with an expression for the length. Well, here's the sentence. The length is 2 more than the width. 2 more than means add. So I'm going to do 2 plus the width, but the width is w. So the length is 2 plus w. All right, let me go ahead now and write out an equation to get started. Well, I know this problem is talking about the area of a rectangle. Well, area of a rectangle is length times width. I remember that from geometry. They're telling us the area is 22 in this example. I'm going to ignore this m squared. M squared is just the units, meters squared, but I don't need those units. So I'm going to ignore that. So area is 22. All right, what about the length? The length we labeled is 2 plus w. And what about the width? Well, we call the width w. All right, we're going to have to solve this equation. Let me go ahead and multiply this w inside the parentheses. So it's going to be 22 equals 2w plus w squared. All right, I'm going to reverse this order just because we usually put w squared in front. So I'm going to write it as w squared plus 2w equals 22. All right, well, part A, this question says, write the quadratic equation in standard form. Standard form means set equal to 0. So let me go ahead and subtract 22 from both sides to get it into standard form. So I got 0 equals w squared plus 2w minus 22. All right, I think this is the equation they want for part A. Let me type this in and see if this is what they want. So they want w squared plus 2w minus 22 equals 0. Folks, notice I'm being careful here to use capital W in my answer because that's what they told me to use. They told me to use a capital W. All right. All right, well, we have that part done, but now they want us to actually figure out the width and the length. So that means I got to solve this quadratic equation. All right, let's do it. Well, I think I'm going to try the factoring method here. So let's try to factor it. All right, well, I'm going to put a w and a w in front here because I know this w times that w will get me back to w squared. And back here in these blue boxes, I need two numbers to multiply to negative 22. Well, if they're going to multiply to negative 22, one number has to be positive, the other number has to be negative. So I'm going to try plus 11 minus 2. Let's see if that works. Plus 11 minus 2. All right, if I multiply this back, I would get back to a, and you know what I'm noticing, folks, we really can't factor this. I thought we could factor this, but you know, this would get us a 9w. So no, that's in the middle. That's not going to work. So I don't think we can factor this. So we have to turn to the quadratic formula instead. All right, so let's do that. I'm going to work out then w equals negative b plus the square root of b squared minus 4ac all over 2a. All right, well, in our example, a is 1, b is 2, and c is negative 22. All right, so let's go ahead and plug in. This is going to be negative 2 plus the square root of b squared. Let's see, that's going to be 2 squared minus 4 times 1 times negative 22. All over 2a, that's going to be 2 times 1. All right, well, I'm going to work this out on my calculator. Let's see here. I'm going to work this out. Let's see what I end up with. Negative 2 plus the square root of, actually, let me work out the square root manually here because we can do this easily here. 2 squared is 4 minus, now I'm going to do this multiplication. 4 times negative 22 is a negative 88, all over 2. But 4 subtract negative 88 under the square root symbol flips to be 4 plus 88. 4 plus 88 is 92. So this is 4 plus the square root of 92 divided by 2. And if I do that, I'm getting 3.7958. And I'm noticing it says type round to 2 decimal places. So I think our answer is going to round to 3.80. Now, if you remember, there's a second solution. The second solution would be negative b minus the square root of b squared minus 4ac over 2a. If I was to work out that solution, I would end up with a negative number. But I can't use that solution because remember, we're talking about the width of a rectangle, the width of a patio. I can't have a negative answer for a width. So that answer I would just ignore. It doesn't make any sense. So what we're coming up with is the width is 3.80. Well, the length is 2 more than that. So the length is 2 plus 3.80, which is 5.80. And I can go ahead and type those answers in. Let's do it. So the width is 3.80. That's what we came up with. And here they want me to use the units. Well, anytime you're talking about width or length, those are just meters, m. And the length is 5.80. And that is also just going to be m meters. Let's see if we did all these calculations correctly. Yep, looks like we did. All right, folks. Maybe we could do one more example. Let's do one last example here. All right, let's take a look at this one. It says the height of a fireworks shell shot vertically as a function of time is this kind of an equation. How long should the fuse last so the shell explodes at the top of its trajectory? Well, I'm going to try to come up with some kind of a graph here to help me interpret what's going on. Now I'm noticing this is a quadratic equation because it has a t squared. When you go to graph a quadratic equation, it's either going to graph as a parabola that opens up like this, or a parabola that opens down like that. The way you know which way the graph opens is you look at the number in front of the t squared. If the number in front of t squared is positive, so number in front of t squared is positive, then the graph opens up like this. But if the number in front, and of course in our example, it's negative 16t squared. If the number in front of t squared is negative, like it is in our example, then you know the graph opens down. So in our example, we know our graph is going to open down like this. So this is going to be the height of the rocket, and this is the time. So what they're asking us to do is find this time, let's call it t here, t equals question mark, so that the rocket explodes right at the very highest point in its trajectory. Well, we call this point up here the vertex. So the vertex is either the very top of the graph, or the vertex could also be the very bottom of the graph. In our case, we want to find this vertex here, which is the top of the graph. Well, there's a formula to find the x value of the vertex. Here, we're really using t instead of x. But to find the x value of the vertex, all you have to do is work out x equals negative b over 2a. Instead of using x, we're using t here, so I'm going to use a t. All right, so let me take our equation and compare it to that standard form. Here's the equation they're giving me. And I'm going to compare this to at squared plus bt plus c. Well, I'm noticing a is negative 16. Our b number is 104. And our c number is 8. So let me plug in. This says take the negative of b. That's going to be the negative of negative 16. And on the bottom, 2 times a, I'm sorry, negative b is negative 104. Whoops, wrong number there. Right, negative b is 104 here. And 2 times a on the bottom is 2 times negative 16. So this is going to be negative 104 divided by negative 32. A negative divided by a negative is a positive, and 104 divided by 32 is 3.25. So it's going to take 3.25 seconds. So our answer here is 3.25 seconds. It's going to take about 3.25 seconds for this fireworks to reach its maximum height. So the fuse should burn for 3.25 seconds in order to have the fireworks explode at the very top of its trajectory. All right, let me go ahead and enter this answer. Let's see if we did all this correctly. 3.25. Oh, it's incorrect. Aha, good, we checked. Let's go back and see what is going on here. Oh, I think I typed it. I typed a comma by mistake. Whoops, my typo. This should be a 3.25. Let's try that. All right, that's right. All right, folks, give these examples a try. Remember to please use these view an example, help me solve it buttons. Let me know if you have any questions. Hope this is helpful here as you're working in this module 4 skills practice.